Number 11. Complete the following table. Now, this is actually kind of simple. What are the components of metals? Well, they're atoms. You put those atoms together in a metal sample, and then those metals will take care of the rest. They will donate. They will donate their valence electrons, and those valence electrons will make the sea of electrons. But what you're putting together in the first place are simply metal atoms. That's it. They're just metal atoms. Whereas for an ionic compound, you have to first ionize them. You have to ionize them first. So what goes into an ionic compound? Ions. Now the overall charge is going to be neutral. Okay, we definitely do not want an overall charge. That infers a little bit of instability, the readiness to react. So for a metal sample, there's going to be an overall neutral charge, because remember, aluminum starts out neutral because it's got the same number of electrons and protons. If it's going to donate 3 electrons into the electron C, there's a -3 charge in the electron C now, but that aluminum itself now has a +3 charge. So it's always going to be balanced, so it's going to be neutral. One of the facts that we need to remember about ionic compounds is that they are always going to be neutral in charge. Okay, there are several slides in the PowerPoint notes that were dedicated to that idea, that unless the charges, the positive charge and the negative charge, completely balance each other out, that's not an actual real ionic compound. Metals, are they conductive in the solid state? Yes, they are. Ionic compounds, however, are not. Metals can have anywhere from a low melting point to a high melting point. Most of the time, we think of metals as having a very high melting point because most of them do. Remember, mercury, however, is a metal, and it's a liquid at room temperature. If you put some in your hand, which I don't suggest, it's a liquid. Okay? It is a liquid. And so the melting point of metals is anywhere from low to high. Whereas ionic compounds, it is always high. Very, very, very high. There is no little exception. There's no, like for the metals, like mercury has a really low melting point. There's nothing like that. They're all high. Hardness. When we were talking about metals earlier in the year, we identified the main group 1 metals as actually being very soft. You can kind of just like cut them with your fingernail. But then again, you're not really going to have pure sodium in your hands. It's not really going to happen because it's pure sodium, and that's not safe. But they're pretty darn soft. However, there are the metals that we think of, things like titanium or aluminum. They are very, very hard. So anywhere from pretty soft to very hard. Ionic compounds, however, are always hard. Yeah, they're always hard, very, very brittle. Metals, are they malleable? Yes, they are. Okay, they can be hammered into sheets. Are ionic compounds malleable? No, they are not. They will shatter. Metals, are they ductile? Yes, they are. They can be drawn into wires. Ionic compounds, are they ductile? No, they are not. If you try to draw them into wires, they will shatter.